Welcome back to the Algebra 2 series. This video is a continuation of the 5.2 to 5.4 video, second half, where today we're looking at rational inequalities. And of course, the first thing we notice is that this inequality is already being compared with 0. Our fraction has two parts to it. In the top part, or the numerator, we see that -2 is the number that would make that 0. And in the bottom, the number 1 is the number that would make that 0. So when I see that, I typically then will say, okay, on my number line, I'm looking at three different parts. I'm looking at the part from -infinity to -2, the part from -2 to 1, and the part from 1 to infinity. Neither of these numbers will work since the inequality here is showing greater than. So in this case, we see that we don't have an equal sign underneath there. Well, the next part of this is to work out the signs, and as we've done in the past, if we pick a large positive number like, for example, 10 or 11, and we plug it in over there, we would end up getting a positive over positive, and that will be greater than 0. So that becomes a positive here on my number line. The factors are all to the first power, and we learn in class that when they're to the first power, these signs will alternate properly. So we'll have this going on, and we could test a number like -10 or -11 and see that it's, in the case of -11, we'd have a negative over a negative, which comes out to be a positive in the end. So to answer the question, what numbers, oh, that's an ugly brace, what numbers answer the inequality, we would write x such that x is less than -2 or x is greater than 1. Those would be the two areas. Now we could also write this in interval notation. We'd write x on the interval from -infinity to -2, and then we use a parenthesis at -2 because that's not included, and then we go from 1 to infinity. So those would be our two ways of answering the question. We could either do it in interval notation here, or we could do it in set notation. Either way is correct. Let's move on to the second question then. Here we have another one, but this one is not in factored form yet. And you'll see a couple of interesting things happen with our sign chart. Because we have a 0 on the right-hand side, we're happy about that because we can set up our sign chart right away. But in the denominator, I'm going to factor this out into x minus 2 and an x plus 2. And that way, I can see the numbers kind of easily on my little sign chart here. 0 for the numerator. This is from the top part here, giving us a 0 to make that 0. And then in the denominator, we see 2 would make the first binomial 0, and -2 would make the second one 0. And one of the points on this one is this is kind of an interesting problem because notice that this is less than or equal to, and therefore, if you plug in a 0 for x in that numerator, you will make an equals. You will make an equality with that so that it does include 0. However, in the denominator, you can't have a 2 or -2 because that would make a 0 in the denominator. So these are open circles. So I put that in my number line just to remind myself that, hey, I need to include 0, but I don't want to include the 2 or the -2. Now let's go through our sign chart again. In this case, picking a large positive number like 11 again, we would see in this case a positive over a positive times a positive. So in that case, we would get plus right here. The x minus 2 is to the first power, so that will alternate right there. And then at 0, notice that the x is to the second power. That implies that there is no sign change. So we'd end up with negative, negative, and we can't help but see the little guy sitting there smiling at us. But anyway, that means that there is no sign change across 0, but then there will be a sign change over here. We could test a couple of numbers in those intervals as well, but we use our technique of noticing if this is a power that's even, there will be no sign change at that root. And let's go ahead and finish the answer then. In this case, the question is, where is the inequality going to work, or where is the fraction going to work for numbers less than or equal to 0? So the values that this fraction has to take on have to be less than or equal to 0, and that all appears between -2 and 2, and it does include 0. So we would write in set notation x such that, and just write it as an inequality from -2 to +2 in interval notation x on -2 comma 2. Now that looks like an ordered pair, but it's not an ordered pair. It is interval notation, and that's why we write the word, the letter x on, and this tells the reader that we're talking about an interval, not an ordered pair. Well, let's finish the last problem here then. This one is a little bit tricky because of that number not being a 1. Let me write this out again. This number is a 1, and so this is very sad because we have to figure out how to get it to be a 0. And that means we're going to have to algebraically manipulate things a bit. So if I rewrite this and bring the 1 to the other side, now I have a 0, but I don't have a single fraction. So I'll do a little bit of math work here, a little algebra, no problem. This is going to be an x plus 4. And then this one, there's the 1, and I'm going to write an x plus 4 over an x plus 4 to make a common denominator. That will give us a way to combine those two terms. Let me continue with this here. So I have my 2x squared plus 1. Then I've got this minus x plus 4, and that's all over a single x plus 4, bringing that together as a common fraction. So 2x squared plus 1 minus x. Ooh, that's ugly. Let me rewrite that. Minus x minus 4. I have to be careful with that one. X plus 4. And then finally, 2x squared minus x minus 3 all over x plus 4. And I believe this is going to factor in the numerator, which would be wonderful if it did. This would end up being 2x and then x. And then I think the 3 will go here, and then a 1 over here. I think it's plus minus x plus 4 greater than or equal to 0. So now we'll use the technique that we've seen before. Everything is set up to go. We have three numbers, -4. We have -1 and +3/2, those from the binomials. And using the same technique as I did in the last problem, notice that the -4 is in from the denominator, so that's automatically an open circle. Whereas the -1, and this is an equals here, greater than or equal to, so I'm going to need this guy, and I'm going to also need that guy to be included in our answer set. Well, here we certainly want to work our signs out. All three terms are to the first power. This is all to the first power, so we'll have alternation of signs. Starting on the far right, I usually use the positive values first. That's going to be plus, and then minus, and then plus, and then minus. Of course, they alternate when the powers are to the first power. When the power is squared, or the 2, then, of course, it won't alternate at that position. So finally, if we write this in set notation, x such that, we're looking for where it's greater than or equal to 0, so positive areas. This would look like x is going to be greater than -4, less than or equal to -1, and the second place would be greater than or equal to 3/2. I believe that is the correct answer there. And then, of course, in interval notation, x on, this case we would write a parentheses for the -4, and then the -1 gets a bracket, comma, bracket, 3/2 to infinity. Now that is a very strange looking interval notation, but that's correct for those values. Oops, I seem to be losing control of my little wand here. Well, I'm going to stop right here, and hopefully that will be the last part of it. It's hard to tell if I'm still... Oops. Oh gosh, I hope I'm able to get this in there.